Hi everybody and welcome to the second video on a series that shows you how to build an 8-ball pool game with JavaScript and HTML5.
In the last video, we implemented the shoot method on both the stick class and the ball class so that when we'll release the left button on our mouse, it will shoot the ball towards the position of the pointer. And we also display this shooting animation as you can see right here on the canvas. Okay, so now I'll open the vector2.js file, and there I want to add a method so I could get the length of a given vector. So vector2.prototype.length, and that will be equal a function. And here I'm going to return the result of the length formula on the given vector, and I'm going to calculate that using the math object of JavaScript. Okay, great. Inside ball.js, I want to add another property to the ball class that will indicate whether the ball is moving or not. So this .moving will be initially false. And inside the update method, I want to set it to be false if this .velocity.length is less than, let's say, 5. So if that happens, I want to set this .moving to be false. And before that, I want to set this .velocity to be a new vector 2. So its x and y values will be zeros. And inside the shoot method, after I change the velocity, I want to set this .moving to be true. And I'm going to add another property to the stick class, and I'm going to call this property this.shot, and initially it will be false. Maybe I can find a better name, but for now that will do. And inside the shoot method, I want to set this.shot to be true. And inside the game world, we'll implement another method that I will call gameworld.prototype.balls moving, and that will be equal a function. And for now we only have one ball that this object contains, so we'll return this.whiteball.moving. Inside the update method, so if all the balls stop moving, so if this balls moving, and if this stick shot is true, so sorry, if not this balls moving, I'll call a method inside the stick object that I will name reposition, and I will send this.whiteball.position. So I want to reposition the stick to the new position of the white ball. So let's open stick.js again, and here I'm going to implement this method stick.prototype.reposition, and that will be equal a function that will get a position as an argument, and it will set this .position to be a copy of this position, the position argument, and I'm going to set this.origin to be equal the stick origin constant, a copy of it. Now back in the browser, let me refresh, and once the ball stops moving, the stick changes its position to be the same as the new position of the white ball. Just one final thing before we move on. on the reposition method that we just wrote, let's set this dot shot to be false. And let's see that everything still works as it should. Okay, great. In assets.js, let's load some more sprites. So the first one will be the sprite of the red ball, and the second one will be the sprite of the yellow ball, and the last one will be the sprite of the black ball. Now I will create a new file that will go by the name of color.js, and there I'm going to define something that we call in other languages an enum, and it will contain all the different colors that we use on our game. So red, yellow, black, and white, and each color is going to have a different value. Back in assets.js, I will implement a helper function that will provide me the sprite that I want based on the color that I will send it. So I will call this function getBallSprite by color, and it will get as an argument a color. And here I'm going to create a switch case statement. So switch color, and in case the color is color.red, I will return the red sprite. Okay, so I filled it up with the rest of the colors, and now we can go to the ball class and change the function constructor so it will get a color as an argument. And here I'm going to set the sprite, this dot sprite, to be get ball sprite by color, and to send the color that we got as an argument. And here in the draw method we can just delete sprites.whiteball and send this dot sprite instead. So now we have to go back to the game world and to send the color that we want for the white ball, which is of course white. And let's go to the index.html file and add a reference to the color.js file that we just wrote. So script src, and that will be equal color.js. Back in our browser, everything still works fine. In purpose of testing, let's change the color to be red, and let's refresh the browser, and that also works. Great. So let's change it back to be white as we want it to be. Okay, so let me paste a bit of code here because I don't see the point of writing it all again. What you see here in front of you is an array that contains all the different arguments that we need in order to create our ball objects. So you can see that each element in this array is actually a pair that contains a position and a color. And eventually we use the map function in order to take every parameter and to pass it into the ball function constructor to create a new ball. So at the end of the day, what you get is that this dot balls contains all the balls, all the ball objects that we need in our game. So down here, instead of creating a new object for the white ball member, we can just refer it to the last object in the array that we just created. And maybe we'll change it in the future, but for now that will do. And down here in the update method, we can just loop over this array and write for let I equals 0, I is less than this dot balls dot length, I plus plus, and to call this dot balls at I dot update, and to send the delta, of course. And let's copy that and paste that on the draw method, so we can loop over the array, and instead of calling the update method, we can call the draw method. So back in our browser, finally, you can see that our setup, at least visually, is pretty much complete. And if I'll shoot the ball towards any direction, really, as soon as the white ball stops moving, the stick repositions itself to the new position of the white ball. Okay, so there's something that I need to fix before we move on. Now that we have more ball objects, it's not enough to check only if the white ball is moving on the ball's moving method. We want to loop over the array and to see if any of the ball objects is moving. So I will set a new boolean, balls moving, to be false, and let's loop over the array this dot balls dot length I plus plus, and if this dot balls at I is moving, we can set balls moving to be true, and we can break out of the loop. Now we will return balls moving. Back in our browser, let's see that everything still works. Yeah, that looks fine. Now in vector2.js, we'll need to add some more operations to support the collision system that we're going to implement later on. So we'll add here a new method. So vector2.prototype.add, and that will be equal a function that will get another vector, and we're just going to return a new vector that will be the sum of both vectors. So this.x plus vector.x and this.y plus vector.y. Let's add another one, and let's call this one subtract. And here I will return the subtraction result of the vector argument from this vector. And the last one for now will be the dot product. So vector2.prototype.dot, that will be equal a function that will get another vector, and this function will return the result of a dot product operation between both vectors. So that will be this.x multiplied by vector.x plus this.y multiplied by vector.y. Now let's go to our game world, and there on the update method, before we do anything, we want to check if collisions occur. So let's write a new method for that, and let's call it on the update method. Let's call this method this.handle collisions. So game world.prototype.handle collisions, and that will be equal a function. And inside this function, I want to loop over the array in a certain manner that will provide me all the possible pairs of objects. So for let I equals 0, I is less than this.balls.length, I plus plus, and inside the nested loop, I'm going to declare let j be I plus 1, j is less than this.balls.length, I and I plus plus. Okay, so inside this loop, let's get the first ball out of the array. So first ball, that will be equal this.balls at I, and const second ball, and that will be equal this.balls at j. And I want to write something like first ball dot collide with second ball. And of course, we need to implement this method in order for that to work. Let's see that everything is fine here. Oh, actually, I have a mistake inside the nested loop, and we need to increase j, so j++. Okay, so now let's implement the collide with method inside the ball class. So ball.prototype.collide with, and that will be equal a function that will get a ball as an argument. Okay, so this is the moment we all have been waiting for. Elastic collision in 2 dimensions. And before I begin, I must give a huge credit to Chad Burchek, who wrote an article about this subject in 2009. And this article explains everything in a very simple manner. And even if you don't have a mathematical background, I really encourage you to go and read this article. I will leave a link in the description down below. And really, it's very easy to read, and it explains everything just beautifully. So go and read this article. One more thing that I want to say before we begin is that I'm going to provide you with steps on how to implement elastic collision in your code, but I'm not going to get too deep inside the mathematical proofs and concepts. Okay, so now that we're all set, let's begin. Step 1. Finding a unit normal vector. A unit normal vector is a vector that has length of 1, which is perpendicular to the surfaces of the balls at the point of the collision. In order to find a unit normal vector, we need to find a normal vector first, and we can do that by subtracting one of the ball's position from the other ball's position. So back in our code, in the collide with method, let's find a normal vector. And let's scroll down a little bit so it will be easier to see. Okay, that's better. So const n, and that will be equal this dot position subtract, and we'll send ball dot position. From this normal vector, we can also get the distance between the centers of both balls. And this will indicate us whether a collision occurred or not. So let's find the distance, and let's set const dist to be n dot length. And if the distance is greater than the ball's diameter, then we want to return from this function because there is no collision between both balls. Let's not forget to set another constant that we'll call ball diameter. And in our case, that will be 38. Okay, so now let's find a unit vector of n. And we can do that by taking n and multiplying it by 1 divided by its length. Okay, so now back in our code, let's write a new comment, and we'll declare here that here we're going to find unit normal vector. Let's set const un to be n multiplied by 1 divided by n dot length. Step 2, finding the unit tangent vector. Back to the drawing, you can see that the unit tangent vector is a vector that has a length of 1 and is tangent to the surfaces of the balls at the point of the collision. We can find it by using our unit normal vector that we already found. We just take the x value to be minus un dot y, and the y value of the unit tangent vector to be un dot x. Back in our code, let's write a new comment, finding unit tangent vector, and we'll set const ut to be a new vector2 object that its x value will be minus un.y and its y value will be un.x. Step 3. Resolving the velocities into normal and tangential components. So we're doing that by performing a dot product operation between the velocities of the balls and the un and ut vectors that we already found. Back in our code, let's write a comment, project velocities onto the unit normal and unit tangent vectors. Okay, let's go one by one. So const v1n, and that will be equal un dot this dot velocity. Const v1t, and that will be ut dot this dot velocity. Const v2n, and that will be un dot ball dot velocity. And finally, const v2t, and that will be equal ut dot ball dot velocity. Step 4. Find new normal velocities. We want to find the normal velocities after the collision. And for that, we can use the formula for collisions, for elastic collisions in one dimension. And because both of our objects have the same mass, what we get here is rather simple. If we just put our values inside, we get that v1n tag means after the collision, will be equal to v2n, and v2n tag stands for after the collision, will be equal to v1n that we already calculated in the previous step. So back in our code, that will be pretty easy to implement. So let's just write a new comment first. Find new normal velocities, and we'll set let v1n tag be equals v2n, and let v2n tag be equals v1n. Step 5. Now we want to convert the scalar normal and the tangential velocities into vectors. And for that, we need to make some few multiplications between the vectors and the unit normals and the unit tangent that we calculated before. So let's go back to the code and implement that. So back in our code, let's write a new comment, convert the scalar normal and the tangential velocities into vectors. So v1n tag will be the unit normal multiplied by v1n tag, and let's set const v1t tag to be ut multiplied by v1t, and let's set v2n tag to be equal un multiplied by v2n tag, and let's set const v2t tag to be equals the ut multiplied by v2t. Step 6, the final step for now. Update velocities. Now we need to update the velocities of our ball objects according to the equations that you see right here in front of you. So back in our code, let's write a new comment and let's write update velocities. Yeah, finally. So let's set this dot velocity to be v1n tag add v1t tag and ball.velocity to be v2n tag dot add v2t tag. And now let's set this dot moving to be true, and let's also set ball dot moving to be true. Okay, so now back in our browser, let's test the results. I'm really excited. Let's see what happens. Okay. So we do have collisions, but we also have an issue here because you see that the balls kind of merge together, and that's not good for us. There is a way to fix that, and let's do that. Let's fix that. Okay, so back in our code, we will need to find the minimum translation distance, which is the minimum distance that an object, a colliding object, can be moved in order to not collide anymore with the other object. So const minimum translation distance, MTD, will be equal the normal that we calculated before multiplied by the ball diameter minus the distance divided by the distance. And I should put this part in parentheses. Okay, so now let's push and pull the balls apart. Okay, so let's do that by setting this dot position to be this dot position dot add, and I will add the MTD multiplied by half, and I will set ball dot position to be the ball dot position dot subtract MTD multiplied by half. Okay, so back in the browser, let's test the results, and hey, whoa, this is actually working. So let's try another one here. Yay, great. Okay, so even though the physics that we implemented in this game are 100% correct, we still got an issue here. Let me demonstrate and let's see if you can spot it. Okay, did you get it? Let's watch that again in slow motion. Here you'll see that at the time of the collision, some of the balls overlap each other. And that happens because it detects the collision too late, when the balls are already on the same area. Back in our code, in order to minimize that unwanted effect, I will try to tune some of the constants. So let me start with the delta, and let's set it to be 1 divided by 177, and that's just the number that I came up with. And let me just remind you that the delta defines how much of the ball's velocities we will add to the ball's positions on each iteration of the main loop. Now in the ball's update method, we will multiply the velocity by 0.984 in the part of the code where we apply friction. And let me just write it in a comment. So here we apply friction, and again you can choose any number that suits your needs. Back in our browser, now it looks much better. But since we decreased the value of delta, it seems like the stick doesn't hit the white ball with enough power. So back in our code, inside the increase power method of the stick class, we will increase every time by 120, and let's set a maximum power. So if this dot power is greater than max power, I want to return from this function, and let me just set const max power to be for now 8,000. Now let's check the result, and I don't know, maybe we'll change it to 7,500. Okay, so I think that's better. Please take your time and tune those numbers until you will get a result that will satisfy you. Of course, that's not a perfect solution to the problem, but that will do for now. If you want, you can read more about something called quad trees and how to use it for collision detection, but that's beyond the scope of this tutorial. Inside the game world, I'm going to create a new member that I will call table. And this .table will be a new object literal that will contain the x and y values of the borders of the table. So top y is 57, and the right x value, the right border's x value is 1443, and the bottom y value is 768. And the left border's x value is 57. Now inside the handle collisions method, inside the first loop, I want to write something like this.balls at I dot collide with, and instead of sending a ball, I want to send a table, the table that we created. So in order for that to work, I will create two more methods inside the ball class. And the first one I will call ball.prototype.collide with ball, and that will be equal a function that will get a ball as an argument. And the second one will be ball.prototype.collide with table, and that will be equal a function that will get a table as an argument. So now let me just copy all the content of the collide with method that we wrote for ball-to-ball collision, and let me paste that inside the collide with ball method that we just wrote. And here I'm going to change the argument to be called object instead of ball inside the collide with method. And I'm going to check if object is instance of ball. And if it is, I'm going to call the collide with ball method, and I'm going to send this object. And else, I want to call this dot collide with table and to send the object. Okay, so back in the browser, we see that table is not defined. So let's go back to the game world, and instead of sending table, we need to send this dot table. And let's check again. So again, table is not defined, and this time it's on the collide with method. So here I sent accidentally table instead of object. So let's go back to the browser and let's refresh and see that everything still works. Yeah, it does. So back in our code, in the collide with table method, the first thing I want to do is to check if the ball is moving. And if it's not, I want to return from this function. Next, I will set a new variable that I will call collided to be false. And before I move on, I need to create a new constant that I will call the ball radius, and it will be half of the ball's diameter. Now I want to check if this dot position dot y is less or equal to the table dot top y plus the ball radius. And if that happens, I want to set the velocity to be a new velocity that its x value will be the same x value of the previous velocity, and its y value will be minus this dot velocity dot y. And I want to set collided to be true. Now let's test the results on the browser, and that looks like it's working. So now let's do the same thing for the right border. So this should be x instead of y, and this should be right x instead of top y, and this should be greater or equal, and this should be minus. I hope you guys are following. And here, instead of minus this dot velocity dot y, I need to make the x value to be minus the x value of the previous velocity. So now let's refresh the browser and test the right border, and that seems like it works. So back in our code, we need to do the same for the bottom one and the left one. So let's start with the bottom, and that should be greater or equal, and this should be bottom y, and that should be minus the ball radius, and the code inside should stay the same. So let's refresh and let's test, and that looks fine. So now the last border, let me copy that and paste that here, and instead of greater, it should be less than or equal to left x plus ball radius. And same here, we don't need to change the code inside the if statement. Let me just refresh the browser and let's see. And yeah, all the borders, collisions are working. So one final thing that I want to do inside this method is to decrease the velocity in case of collision. So if collided, so this dot velocity will be this dot velocity multiplied by 0.98 to simulate energy loss. Okay, so let's test the results. Let me refresh and let's shoot the white ball towards the other balls. And hooray! So you can see that we pretty much finished implementing the physics for this game. I'm sure there are still some bugs here and there, but we'll find them on the go and we'll fix them all. And this was it for this video. Thank you very much for watching it, and stay tuned for more. Goodbye.